According to the U.S. Geological Survey's USGS Yellowstone Volcano Observatory report, published in March, field research over the past year has provided new geological evidence that the formation of the Yellowstone caldera is much more complex than previously thought. A caldera is a large crater that forms after the collapse of a volcano due to an eruption. Yellowstone is one of the largest volcanic systems in the world. It sits atop one of Earth's hot spots, which are areas in the mantle where hot plumes rise and form volcanoes in the Earth's crust. The volcano has produced 3 caldera-forming eruptions in the past 3 million years. The Huckleberry Ridge Tuff eruption, 2.1 million years ago, the Mesa Falls eruption, 1.3 million years ago, and the Lava Creek eruption, 631,000 years ago. The Huckleberry Ridge Tuff and Lava Creek events are considered supereruptions because they ejected more than 240 cubic miles, 1,000 cubic kilometers, of material. The latter is responsible for the formation of the Yellowstone caldera. Mesa Falls erupted 67 cubic meters, 280 cubic km, of material. So although it is still about 10 times larger than the eruption of Mount St. Helens of 1980, is not considered a supereruption. Previous research suggests that the Lava Creek supereruption did not occur suddenly. Deposits in the Sour Creek Dome area east of the national park indicate that the giant explosion was preceded by at least one eruption. Volcanic rocks formed through the deposition of a mixture of hot materials ejected during the eruption found at the site had completely cooled before the main Lava Creek eruption occurred. To better understand the eruption timeline, scientists spent 2022 remapping and collecting samples at Sour Creek Dome. It has long been known that there are at least 2 geological units, volumes of rock distinct from those surrounding them, that originate from eruptions, and it is thought that there is little or no time gap between them. Michael Poland, scientist in charge at the Mountain Observatory Yellowstone Fire, told Live Science via email. Now, we think there are more units. And we're not sure what the time gap is, if any. So far, the team has discovered 4 previously unknown ignimbrite units at Sour Creek, indicating at least 4 eruptions. They also discovered 2 structures that look like eruptive vents, which may have been the source of the rocks. That could mean some vents are active and/or there is a time lag between eruptions, Poland said. But we don't yet have the data we need to answer those questions. Scientists discovered the Huckleberry Ridge Tuff eruption that emitted twice as much volcanic material as Lava Creek produced was also a gradual event. Analysis of rocks at the location shows that there were 3 separate eruptions, with a time span of weeks to months between the first 2 eruptions, and years to decades between the second and third eruptions. Yellowstone volcano is not expected to erupt anytime soon. However, the finding that the Lava Creek eruption may have followed a similar pattern to the Huckleberry Ridge Tuff eruption may provide an idea of what will happen if and when Yellowstone does erupt. The large eruption that formed this caldera was probably not a single event at Yellowstone, but had several phases, Poland said. Researchers at the volcano now plan to carry out a detailed examination of the newly discovered units and the boundaries between them. This will allow them to provide a more detailed picture of what the Lava Creek eruption was like, and perhaps even what triggered it.